You see this hand pump? It's pumping water out. But where is the water coming from? That's exactly what I'll tell you. You know, the rainwater and water from other water bodies seeps down into the soil and is stored as groundwater. So the hand pump was pumping out this groundwater. Now, there is a name for this process through which the water passes down through the soil, and that is known as infiltration. This infiltrated water accumulates in the deep underground, at which point where a layer of impermeable rocks are there. By definition, impermeable rocks don't permit the water to seep down any further. And these places that have impermeable layer of rocks are known as aquifers. Have you heard of that before? So due to infiltration of rainwater or water from other bodies, it passes through the porous soil and recharges the groundwater. And this water in the aquifers is what is pumped out using this water pump.
Groundwater. So we're going to start with the nature of aquifers and confining units. So what is an aquifer? Aquifer are bodies of rock or sediment through which groundwater is able to move or flow. So an aquifer is an underground layer of permeable water-bearing permeable rocks. So when we say groundwater first, what is groundwater? It will be discussed by the next group member. So for now, groundwater is from the word itself, water found underground. So aquifers is a groundwater layer of water-bearing permeable rock. So what is permeable? Discussed by the previous reporter, permeable is, we have here copies. Permeable is allowing liquids or gas to pass through. So rocks in this layer, in the aquifers, have cracks and fractures. Those cracks and fractures are connected to one another. Because of it, water is able to flow through it. So that is what's called permeability. Because of these spaces, water is held in this layer and aquifer is formed. So this is the aquifer. Another characteristic of aquifer is porosity. Porosity is the spaces within cracks and cavities of a rock or a material. So porosity from the word pores, pores means holes or spaces. So these cracks are pores. So for you to visualize, compare aquifer to a sponge. Do you know a sponge? Dish sponge. The one we use at home to wash dishes. So this sponge, when soaked in water, the volume of the sponge does not change, right? Or the size of the sponge does not change, even though it is soaked in water. Why? Because water in the sponge water just fills up the spaces in the sponge. So that is the same in the aquifer. So water from the surface, for example, rainwater or waters from streams, travels underground and then until it reaches this layer of porous and permeable rock, and then water is collected in these cracks. So aquifer is formed. Do you understand? So an aquifer should be both porous and permeable so that water can be buried in this layer. But not all materials are porous and permeable. So here is an example. Gravel, fine sand, clay, or solid rock. In gravel, specific yield, when we say specific yield, refers to how much water an aquifer is able to release. So in gravel, since it is porous and permeable, it has a lot of holes, right? So out of 5 droplets of water can be yielded in a gravel. And then the drainage or the flow of water in gravel is rapid or fast. So next is fine sand. Fine sand which has smaller spaces than that of the gravel. It has 4 out of 5 specific yield, and then the flow of water is moderate. So lastly is clay or solid rock, has 1 out of 5 specific yield because solid rock has compact particles, or compact particles or little spaces, very little spaces. So water in that kind of material cannot flow or is very slow. So because of the differences in materials, aquifers is classified into 2 types. So first type is unconfined aquifer and confined aquifer. So is there on your handouts. So unconfined aquifers, the most common type of aquifer where the water table is exposed to the Earth's atmosphere through the zone aeration. While confined aquifers, these are less common but occur when an aquifer is confined between layers of impermeable strata or aquitons. This is aquitons. So let's explain first what is unconfined aquifer. So unconfined aquifer is not bounded by an aquitard. So what is an aquitard? Aquitard is a body of material with very low permeability, which means it may be clay or solid rock which water cannot flow or only little water can flow near. It traps water. Traps water or aquifer. That's why aquifer is confined or trapped inside. That's why there is confined aquifer. So unconfined aquifer flows freely and goes back to the surface naturally. It is connected in streams. It is not bounded by anything. While confined aquifer is bounded by aquitards or rocks with low permeability. Do you get it?
Lower. No.
Okay, next.
So, we're going to talk about groundwater. So, do you remember the sponge that was exampled by the first reporter? So, the sponge is the actual aquifer, and the water that goes in the water that goes in the sponge is actually example of a groundwater. So,
we all know the Earth is full of water, but there's a lot more to water than all that blue stuff you see on the globe. The water we can see on the surface of the Earth is surface water. Surface water is every lake, pond, river, stream, and ocean on Earth. But in the ground below your feet, there's even more water, groundwater. Groundwater is water that's crammed in the tiny gaps between rocks, soils, and sediments under the ground. A full body of groundwater is called an aquifer.
groundwater is the water that soaks from soil from the precipitation or rain. So as the rain falls, there's a crack between the rocks there's a fragment on the soil or the rocks where water soaks in. So the next topic is zone of aeration or unsaturated zone or vadose zone, where most of the pore spaces are filled with air. So in this drawing we will distinguish the zone of aeration or the unsaturated zone. So in this diagram, the unsaturated zone is where the air is dry, or the land is dry, or the pores or the pores between the rocks are filled with air. So this part is unsaturated zone, or what we call the vadose zone. Next is the saturated zone or phreatic zone that is filled with water. So in this diagram, it is seen that this line represents the water or the groundwater, and top of the groundwater, which is the zone of aeration, and the lower part is the saturated zone. So it means that this part is more of water than rainfall. Then this line represents the water table. What is the top water table? Water table reflects the overall amount of groundwater present in a given area. So, water table is the down part of the zone of aeration and the upper part of the saturated zone. It is the level which the groundwater is in.
So, the next topic will be groundwater. So the first problem would be over-extraction. So what is over-extraction? Extraction rate is lower than replenishment. So the space is kept constant, thus result to net reduction in intergranular space, which decreases the volume of rock per centimeter cubed. So over-extraction of groundwater, there is this thing that we call replenishment. So when there is less replenishment, there is less fresh water in the there is less fresh water. So this over-extraction results to subsidence. So what is subsidence? You can read it in your handouts. So subsidence is a result of decrease in volume and it is caused by over-extraction. Subsidence also results to greater chance of flooding in an area. It is also irreversible. And the next one, it is saltwater intrusion. So from the word itself, intrusion, salt water, when it reaches the fresh water is not suitable for drinking. So this water table was discussed by Cande. So the water table, when it reaches its boundary, this salt water mixes with fresh water, then therefore it makes water unfit for drinking. So the third and last groundwater problem is pollution or contamination. So contamination occurs when man-made products such as gasoline, oil, road salts, and chemicals get into the groundwater and cause it to become unsafe and unfit for human use. So the first groundwater contamination problem is storage tanks. So in storage tanks, you can easily find sometimes dirt inside storage tanks. So if you would read in your handout, it may contain gasoline, oil, chemicals, and other types of liquids. So over time, these tanks corrode or crack and develop breaks. If the contaminants leak out and get into the groundwater, serious contamination can occur. Second one, septic system. On-site wastewater disposal systems used by homes, offices, or other buildings that are not connected to a sewer system. Septic systems are designed to slowly drain away human underground at slow harmless rate. So septic systems it is connected to our. It is also our drainage systems. It prevents flooding. So if these septic systems get into the freshwater space, it will also be contaminated. Third one, uncontrolled hazardous waste. Hazardous waste sites can lead to groundwater contamination. There are barrels or other containers laying around that are full of hazardous materials. So if factories release oil or chemicals from their factories and they just dispose it on nearby shorelines or freshwater reservoirs, there could be also contamination in water. Fourth, landfills. Landfills are the place where our garbages are thrown. So if these garbages are buried and the soil sips its essence, it could also contaminate groundwater. Fifth one, chemicals and road salts. Widespread use of chemicals and road salts is also another source of potential groundwater contamination. Chemicals include products used on lawns and farm-using trees and insects to fertilize plants. So fertilizers can also be a contaminant to groundwater, especially when not handled well. Sixth one is atmospheric contaminants. Groundwater is a part of hydrological cycle, and if these contaminants get into the cycle, it could also be unfit for human drinking.
Beneath the surface of Texas are extensive water-bearing geologic formations that make up the state's vast and diverse system of aquifers. These aquifers provide more than half of the water Texans use each year. Aquifers are rarely underground lakes like you might see in a cave. They are typically rock formations that are mostly solid, but like sponges, they have interconnected fissures and pore spaces that hold water and allow it to move within the formation. An aquifer is best defined as a layer of saturated rock and the water in its pores. Aquifers are formed very slowly over vast periods of time. Water in aquifers comes originally from the surface of the earth. When rain falls, some of the water infiltrates underground and collects in the pore spaces. Water in rivers and lakes can also seep into the subsurface pores. Eventually, some interconnected pore spaces become saturated with water. In other words, they become an aquifer.
The ability of an aquifer to produce water depends on the properties of the aquifer's rock formation. The two most important properties are porosity and permeability. The porosity is a measure of the volume of empty space, or pore spaces, inside the rock. Pore spaces can be openings between grains, fractures in the rock, and even caverns. Porosity represents the volume of water a rock formation can hold. Porosity itself isn't enough to create an aquifer. The areas filled with water must connect with each other so the water can flow from one pore space to another. That connectivity between pores is known as permeability. Permeability is a measure of how readily water can flow within the rock. Rocks such as pumice and shale can have high porosity, but do not form productive aquifers because the pores within the rock are not connected. The permeability of pumice and shale is low. On the other hand, gravel transmits water quickly because of large connected pore spaces. The permeability of gravel is high. Aquifers are separated from each other by aquitards. Aquitards are impermeable layers that prevent water from easily flowing from one aquifer to another. An aquifer is confined when it is buried beneath other aquifers and/or aquitards. The combined weight of the rocks and water above pressurizes the groundwater. This is sometimes referred to as artesian pressure. When the aquitard above a confined aquifer is punctured by drilling a well, artesian pressure causes the water in the well to rise. Sometimes this water reaches land surface, resulting in a flowing well. Springs are water flowing to the surface through natural pathways caused by the faulting or dissolution of aquifer rocks. Pumping in a confined aquifer causes the pressure of the groundwater to reduce. The reduction in pressure lowers water levels in artesian wells and springs. Because confined aquifers are, by definition, not always well connected to surface water sources like streams and lakes, recharge may be slow, if it happens at all.